probably will.
Will do.
Just let me know. Don't feel
I'll
bashful.
remind you.
Don't feel bashful about it. So what are we doing today?
I've already done the homework, but what we're working on is binomials and binomial formula.
Okay.
Stuff like that.
Okay. So a plus b to the nth power.
The formula we learned was p of x equals probability to the, or equals a combination of n to the x times probability of success to the x times 1 minus probability of success to the n minus x is what we learned.
Okay.
I can.
You have some problems?
No, I don't, unfortunately. I can pull up my thing and read one to you here.
Okay. So what that function you just gave me, the probability of x equals what?
Combination of n on the left, x on the right, times p to the x power. P stands for probability of success, and x stands for successes, number of successes. And then it's 1 minus p to the n minus x. And n stands for the number of trials.
That's the binomial. That's also the binomial theorem. At least I think it counts down. In other words, it's a series, right? So this is not the only term. In other words, its first term is excuse me, can be written like this, correct? Okay. All right, I think I know how to apply this to a problem. If you have a specific problem or something you can read.
Yeah, so this is just kind of a series here, but in the past, there is a 5% chance that it will rain on any given day in October. In the month of October, find A, it'll rain exactly 3 days.
So on any given day, it is 5%. And you want to know in a 31-day period what the odds are that you'll have 3 of them. Exactly. Well, let me think about this for a minute before we proceed. So exactly 3 would be, let me think for a moment. In other words, if they said exactly 1, okay, I think I understand this. I just got to think about it for a second. they said exactly 1, or most 1, it would be 1 minus 5% would be the probability that it does not rain on any given day, times 30 days. So that would be the odds that it did, or to the 31st power, excuse me. That would be the odds that it didn't rain at all. Because the odds that it's going to rain on any given day, or actually the odds that it's not going to rain, are this one, 1 minus 5%. And there's 31 days. Okay, so we should be able to put this as a series. So n is going to be 31 choose 3 times 0.05 to the 31 times 0.95 to the 0 plus, here, let me write this in the more familiar style, 31 choose 3, and then the next term is 31 choose 2 times 0.05 to the 30th power times 0.95 to the first power. Is this something about what you're talking about? Okay. And I believe that the rest of it would be plus 31 choose 1 times 0.05 to the 29th times 0.95 to the 2nd. And finally, we have 31 choose 0 times 0.05 to the 28th times 0.95 to the 3rd. I think that is the answer.
I think when it says exactly 3 days, that you only need to do it for just the 3.
This term only?
Because I think it's when it's like less than or no more than, you do like the multiple.
Oh, if it said anything up to 3 days.
Yeah, then you'd add them all together.
2 days, 1 day, or 0 days. All right. So if I'm doing exactly 3, okay, I guess I get that. So in this case, that gives us 31 factorial over 3 factorial 28 factorial. That's our coefficient times the probability to the 31st power times 0.95 to the 0, which is y. So you're saying that's the answer?
Yeah.
Do you have answers on these?
Oh, wait. For this one, I'm confused.
Well, I'm a little confused too, and I apologize.
So what I did is I did the combination of 31 and 3.
Which is this.
Yep. times 0.05 to the third times 0.95 to the 28th.
Ah, okay. That fits your formula more. Okay. 0.05 to the third times 1 minus 0.05 to the 28th. Yeah, that's the probability to the x times 1 minus the probability to the n minus x. Is that what that second exponent is? Yeah.
Mm-hmm.
Okay. So for any specific number of months, that's n, and number of successes is x. Just fill it in.
Yep.
Okay. So, yeah, if it was anything up to 3 or 3 or less, then I guess I would have to add the other two terms, huh? I would have to figure exactly 0, exactly 1, exactly 2, and exactly 3, and add all of those probabilities together. All right. Interesting. Variation of that is in the book, but I don't think that's in the book specifically. Okay, do you have any other problems you want to apply this to?
Probability that it rains at least once.
In October?
Mm-hmm.
Okay, well, so this is going to be 31, choose 1, times 0.05 to the 1 times 0.95 to the 30 plus probability of 0, correct?
Mm-hmm.
We have to cover 0 and 1.
Well, I think if it's at least, then you have to cover everything but 0.
Oh, it was at least once.
Yeah.
Well, yeah, you're right. In other words, is all we have to do is 0. We have to do this part here and then subtract that number from 1.
Mm-hmm.
Which would be, that's 1. That's 1. So it's 0.95 to the 31st power. 1 minus that should be your answer.
Mm-hmm.
Okay. Hold on a second. There's got to be an erase button on here. I can't find it anymore. There used to be. Okay. What else in the way of questions here?
That's pretty much the expanse of what we're doing.
Okay, so exactly 3 is the first term only, and more than once is everything except 0 and 1. And so if you figure out, or once or more was the second question, is that right?
Mm-hmm.
So you just have to figure out the probability of 0 and subtract that from 1. All right. Yeah. Well, I am looking forward to doing more probability. I'll try to keep up. But yeah, this is the binomial theorem, essentially.
Mm-hmm.
In other words, if you did have a plus b to the x power, then you could use this same binomial theorem, only that's a and that's b. All right. Well, Cole, do you have any other questions? Are you're clearly on probability now? And it will be for how long, do you know?
I think for a while.
Okay, I'm going to hone up on my probability, so I'll be a little bit better, but we'll plan on talking again next Thursday.
All right, sounds good.
Okay? All right. Talk to you then. Bye-bye.
Talk to you then. Bye-bye.